All right, let's get into it. Think about it like this. Imagine a super high security building. Your key card, that decides which doors you can open. Well, in the digital world, your user account is that key card, and some of those doors lead to the most critical, sensitive rooms in the entire system. But what if someone could take a basic lobby pass and somehow turn it into a master key? That's exactly what we're digging into today, the hunt for the keys to the kingdom.
So before we get into stealing the keys, let's talk about what they even are. Just like that keycard, a user's privilege on a computer is all about what you're allowed to do. It's the digital version of an all-access pass, or, a pass that barely gets you past the front desk.
At its heart, the idea is actually pretty simple. A privilege is just a set of permissions. I mean, think about it. Most systems we use every day are built for lots of people, right? From your family computer to a massive corporate server. Privileges are just the basic rules of the road that stop one person from, say, accidentally or intentionally deleting everyone else's stuff and causing total chaos.
But what happens when someone decides they don't want to follow the rules? Well, that's where we get to the real meat of this, privilege escalation. This isn't just about some brute force hacking. It's about finding a tiny crack in the system, a bug, a simple mistake, a small oversight, and prying it open to turn that limited keycard into a master key that unlocks every single door.
Let's try to put ourselves in the attacker's shoes for a second. Okay, so they've managed to get inside the building, they've got that initial foothold, but they're stuck in the lobby. Their keycard is for a low-level user. They can look around, sure, but they can't get into the server rooms, the CEO's office, or the system control center. Their one and only goal now is to upgrade that keycard.
So, this is the big question, isn't it? How do they actually do it? How does an attacker with basically no access find a way to become the most powerful user on the whole system? Well, that is the art and science of privilege escalation.
And the target usually falls into one of two main camps. In the world of Linux and Unix, things are pretty black and white. You're either a regular user or you are root, the all-powerful god of the system who can do literally anything. The goal is simple: become root. Over in the Windows world, it's more like climbing a ladder. Every program runs at a certain integrity level, low, medium, high, and the grand prize system. The attacker's job here is to just keep climbing. So you see, it's the same objective, just two very different playing fields.
All right, so the hunt is on. An attacker with basic access starts poking around the system. They aren't looking for some secret, hidden key. Nope, they're looking for simple, common mistakes. Things left behind by system administrators. And these little mistakes, they're the unlocked doors and open windows that lead to total control.
The fastest way to get power is often the most obvious one. You find a known vulnerability that just never got patched. If the very core of the operating system, the part we call the kernel, is out of date, it's like a bank leaving a well-known flaw in its main vault door, while the blueprints for how to exploit it are just posted all over the internet.
And this process usually follows a pretty clear path. First, you have a vulnerable kernel. Second, there's a public exploit for it. Think of the infamous dirty cow exploit that hit pretty much every version of Linux. All the attacker has to do is get that bit of code onto the machine and run it. The exploit works its magic, tricks the kernel, and boom, they get a root shell, a command prompt with the highest power imaginable. At that point, it's game over.
Now let's move on to a much more subtle, but oh so common mistake: careless permissions. See, this isn't about some unpatched bug. This is about a system administrator giving a regular user or a program just a little too much power. It's like leaving a door unlocked and unguarded, just waiting for an attacker to waltz right through. This classic comic strip just explains it perfectly. Sudo is a command in Linux that basically means run this next thing with God mode on. If a user types make me a sandwich, the computer says no way. But if they type sudo make me a sandwich, the computer says right away. It's a temporary grant of superpowers. And if it's set up wrong, it's like handing an attacker a blank check. So the really crucial part is what you let people run with sudo. A system admin might think, oh, I'll let them run the find command as root. That's harmless. They're just searching for files. But here's the trap. So many of these tools are like Trojan horses. Even a simple text editor like V has a way to run other commands. So if you can run that editor as root, you can just tell it to open up a command prompt as root. And just like that, you've used a text editor to take over the entire computer. And here's what that looks like in the real world. An attacker gets on a machine and they run the command sudo -l. That tells them what special permissions they might have. And look at this. They find out they can run systemctl without even needing a password.
For an attacker, finding this is like hitting the absolute jackpot, because systemctl is a super powerful tool that can be easily tricked into giving up full control. Okay, so now let's talk about a totally different strategy. Instead of breaking the rules, what if an attacker could just trick the system into applying the wrong rules to them? This is a much more advanced kind of attack, and it's all about impersonation and deception instead of just brute force. A classic example of this is something called DLL hijacking on Windows. Here's the playbook. A lot of programs need these little helper files called DLLs just to work. So when a program with high privileges needs one of these files, it sometimes looks in a few different folders to find it. An attacker takes advantage of this. They create a malicious, fake DLL with the exact same name, and they stick it in one of the first places the program checks. The powerful program then accidentally loads the attacker's malicious code, thinking it's the real deal, and runs it with all of its own high-level permissions.
And hey, don't go thinking this is just a Windows problem. The same basic idea works on other platforms too. On macOS, attackers use really similar techniques to inject their bad code into trusted apps that are already running. By hiding inside a legitimate program, like your web browser or a system utility, the malware basically inherits all of that program's permissions, which lets it sneak past Apple's very strict security controls.
So, what's the end game here? The attacker has done it. Using one of these methods, they've successfully turned their basic keycard into a master key. They now have root or system-level privileges. They've become a ghost in the machine, with almost unlimited power. But what does that actually mean? What can they do?
Well, with this master key, an attacker can do pretty much anything they want. They can read all your private files, delete critical system data, install ransomware, you name it. They can dump every user password on the machine to start attacking other computers, and maybe most importantly, they can create a permanent backdoor, making sure they stay in control even if the machine gets rebooted. They've gone from being a temporary guest to the permanent, invisible owner of your system.
Okay, that all sounds pretty terrifying, right? But now for the really important part. Now that we know how the castle gets stormed, let's talk about building higher walls and stronger gates. How do you actually defend your systems against these kinds of attacks? The good news is the defenses are often pretty straightforward. They just require you to be diligent.
It really comes down to these 4 pillars. First, patch your systems. Seriously, this is what closes the door on those kernel exploits, like Dirty Cow. Second, you have to enforce what we call the principle of least privilege. A web server almost never needs to be running as root. Give users and programs only the permissions they absolutely need to do their job, and nothing more. Third, audit those permissions. Check your sudo rules for dangerous commands on a regular basis. And finally, monitor everything. Watch for strange behavior that could be the sign of an attack already in progress.
So in the end, it all comes back to this. Every single system you use, from your laptop right up to the cloud services you depend on, is like a castle with thousands of digital doors. And the question you have to ask yourself is, do you know who holds the keys? And more importantly, do you know just how easily a basic key can be turned into a master key?